Hello everyone. So again we are continue that lesson gravitation and here is your class number 3. Okay. Again we are catering some physics numerical from the gravitation lesson. Okay. So in this chapter we will try to practice some solved questions, solved numericals from your textbook. म्हणजे आपण याच्यात आज जे टेक्स्टबुक मध्ये सॉल्व्ड आहेत हे सोडवलेले आहेत ऑलरेडी. So we will practice those examples. Okay. So without wasting time, let's start with the first example. And it's on your page number 6. हे तुमच्या पान नंबर 6 वरचं एक सॉल्व्ड एक्झाम्पल आहे बघा. एक्झाम्पल नंबर 1. Okay. Now let me read the question. So let us see. The Mahendra and Virat are sitting at a distance of 1 meter from each other. So the distance is given. इथं आपल्याला त्या दोघांमधला डिस्टन्स दिलेला आहे. So its distance is so that d is given. So it's a 1 meter. Now their masses are 75 kg and 80 kg respectively. So let's say the mass of Mahendra will denote that as a m1. Mass of Mahendra. So that will be m1 as 75 kg. And the mass of Virat, let's say m2, that is 80 kg. Okay. And they are asking what is the gravitational force between them. त्यांनी विचारले की त्या दोघांमधला gravitational force काय असेल. So gravitational force साठी आपल्याला एक g constant सुद्धा लागेल, capital G gravitational constant. It's 6.67 into 10 raised to minus 11 Newton meter square per kg square. So let's use just formula for the gravitation force. Using formula F, that is what the gravitational force is nothing but capital G m1 mass of the object 1 m2 mass of the object 2 divided by d square. Okay, so just put the values in the equation and calculate. So 6.67 into 10 raised to minus 11. I'll show you how to calculate the values. Okay, so m1 that is 75 into m2 that is 80 divide d that is 1. Okay, so you're just a 1 square will be 1 only. So whatever the calculation of the power of the tens, okay, तो वो बाद में कर लो, ते परत करा आणि हे जे 6.67 75 जे numbers आहेत, so all that you need to do first. So 6.67 into 75 into 80, so combinedly you will get, first of all we will multiply 6.67 into 75. Okay, 6.67 into 75, we will get answer 500.25 into 80 as it is divided by 1 ka square 1 only into 10 raised to minus 11. Again just multiply that 500.25 into 80. So it will be 40020 into 10 raised to minus 11. And in physics you need to write the answer in the significant form. Okay, so now what is the significant digit, significant number? So your decimal number should be after the first non-zero number. Okay, so पहिला non-zero number कुठला आहे 4 आहे. So after that you need to give the decimal point. So your answer will be 4.002. Okay. Now you have changed the position of decimal point. तुम्ही काय केली तर decimal point ची position change केली. Okay. You have just like तुम्ही किती डिजिट सर्कवला तो 1 2 3 4 5 डिजिट सर्कवला ना इकडे बरोबर. हे 0 हे 2 हे 0 हे 0 असे 5 नाही 4 1 2 3 4 डिजिट सर्कवला ना. सो याच्यातून 7 डिजिट्स हा काय करायचा, हा इकडे कमी केला आपण लेफ्ट साइडला मूव्ह केला म्हणजे मग याच्यातला त्यांचा जो पॉवर आहे त्याची पॉवर आपल्याला वाढवावी लागेल म्हणजे काय आपल्याला ते 10 raised to 8 10 raised to let's say the first of all 10 raised to 10 9 then 10 raised to minus 8 10 raised to minus 7. सो हे -7 पर्यंत येईल. ओके, सो 4 आपण पॉवर वाढवली. मायनस नंबर हा जेवढा लहान होईल तेवढा तो ग्रेटर होत राहतो. ओके, मोठा होईल तो. सो यू विल गेट द फोर्स ॲज 4.002 इंटू 10 raised to minus 7. हे बघा, हे लक्षात ठेवा पॉवरचं. इथं आपण 4 डिजिटने इकडे लेफ्टला सर्कलला म्हणजे व्हॅल्यू कमी केली तर या 10 ची पॉवर जी आहे ती तेवढ्या नंबरने वाढवायची. अँड इट्स युनिट इज न्यूटन. ओके, सो इट्स सिम्पल युअर फर्स्ट न्यूमेरिकल. So just note it down, take a screenshot or just pause it and note it down. Okay, so now we will see the next question. I'll erase it first. Now example 2, see what is given. In our example, assuming that bench on which the Mahindra is sitting is frictionless, the Mahindra starting with zero velocity, what will be the Mahindra's velocity of motion towards Virat after 1 second? So इथं काय दिलंय, सपोज हा बेंच आहे, इथं महेंद्र आहे, ओके, इथं विराट आहे आणि हे फ्रिक्शनलेस आहे, तो महेंद्र या विराटकडे अट्रॅक्ट होईल बिकॉज वी नो दॅट द ग्रॅव्हिटेशन इज नथिंग बट द अट्रॅक्शन फोर्स बिटवीन एनी टू ऑब्जेक्ट्स इन द युनिवर्स. ओके, सो हे दोघं एकमेकांना अट्रॅक्ट होतील इथं. तर आपल्याला काय विचारलंय, याची इनिशियल वेलॉसिटी सपोज महेंद्राची, लेट्स से हा आहे महेंद्र, इनिशियल वेलॉसिटी आहे 0. सो त्याची फायनल वेलॉसिटी काय असेल and will this velocity change with time and how? Okay, so initial velocity of Mahindra is given. We know that the force between them, so let us write force is 4.002 into 10 raised to minus 7. Okay, Newton. We have initial velocity. Then after 1 second, so time is again also given, that is 1 second. Now, first of all, mass is also known. The mass of the Mahendra, M1, I can say. The Mahendra's mass is, I think, 75 kg. Okay, yes. So first of all, we will find out the acceleration because we have the force, we have the mass. So we'll find out the acceleration. So F is equal to mass into acceleration at M1. So mass is 75. Okay, we will modify that formula first. So your acceleration will be F upon mass. So force is 4.002 into 10 raised to minus 7 divided by mass is 75. Okay, so how much you will get? You will get 5.34. If you divide that, 5.34. Just a minute, we will calculate it manually. 4.002 into, sorry, divided by 75. You will get 0.05336 into 10 raised to minus 7. Okay. So as like we already discussed, significant figure म्हणजे हा एक का नॉन झिरो डिजिट नंतर आला पाहिजे. So 5 आहे इथं फर्स्ट. So 5.336 will be 5.34. ओके, सो राउंड ऑफ केलं 6ला आपण इथं. अँड किती डिजिट सरकवला? 2 डिजिट सरकवला डेसिमल पॉईंट. तर मग आता हा राईट साईडला सरकवला तर त्याचा 10ची पॉवर तेवढ्या डिजिटने कमी करायची. सो 2ने आपण सरकवला तर ही कमी करायची म्हणजे इथं मायनस नंबर हा वाढतो, कारण की मायनस जेवढी व्हॅल्यू मोठी होत राहते तेवढी ती कमी होते. ओके, सो दॅट इज वॉट द एक्सलेशन. Now what we need to know, the final velocity. Now you have the initial velocity, you have the acceleration, you have the time. You can find out the final velocity with the help of Newton's first law, first equation, not law, first equation. So using Newton's first equation. So what is Newton's first equation? V is equal to U plus A T. So U is 0 plus A is 5.34 into 10 raised to minus 9 into T, that is 1. So simply you will get 5.34 into 10 raised to minus 9 meter per second, and which is very small. Okay. तर हे जे acceleration आहे ते खूपच कमी आहे, -9. Okay. So that is what the final velocity of the object. Now, second question they are asking, will the velocity change with the time and how? Yes, it will getting changed with the time as they come closer to each other, and as they come closer to each other, so their force of attraction will be increased. Okay, म्हणजे ते दोघं जवळ जवळ येतील. I can write this velocity will change with time as they come closer to each other. Okay, as they come closer to each other, the force of attraction will be increased, and as the force of attraction will get increased, their acceleration goes on increasing, and so that's why it is getting changed with the time. Okay, so you just need to write this velocity will change with time as they come closer to each other, as there is increase in the force of attraction. Also, you can add as force will be increased. So that's how you can write your answer. Okay, so here it is the answer for the second question. ठीक है, सुद्धा एकदा काम करा, like just take a screenshot or pause it and note it down properly. Okay, let me raise this then. Okay, now next question, and that is one additional question on the same page number from use your brain power. Okay, so what they're asking here, assuming acceleration in the example 2 above remain constant, so A remain constant, and what is that acceleration? 5.34 into 10 raised to minus 9 meter per second square. So it remains constant. How long will Mahendra take to move 1 centimeter towards the Virat? So we need to find out the time here, and displacement is given, that is 1 centimeter, and it is nothing but 1 into 10 raised to minus 2 meter. Okay, 10 raised to minus 2, which means 1 by 100. So just convert that into meter, 1 by 100, so it will be 0.01 meter. Okay, so displacement is there. We have the initial velocity u, we have the final velocity also. Okay, so let's find out the time with the help of second formula. Okay, second equation of the motion, using second equation of motion. S is equal to ut plus half a t square. So it will be 0 plus half into a is 5.34 into 10 raised to, sorry, we need to find out not displacement, we need to find out the time. Okay, so okay, again we can use that formula, no issue, but first one is very simple. चलो ठीक है, कोई बात नहीं. S is 0.01. So just do the calculation. 10 raised to minus 9 is here. So 2 will come in the multiplication on the other side, on the left hand side. 0.01 into 2, so you'll get 0.02 is equal to 5.34 into 10 raised to minus 9 to t square. So you'll get t square as 0.02 divided by 5.34 into 10 raised to minus 9. Okay. So 10 raised to minus 9 जर वर घेतलं तर 10 raised to 9 होईल हे. 0.02 divided by करू आपण 5.34. It will be 0.003745. Okay. So again you need to move that decimal point after first non-zero number, that is 3. So it will be 3.75 I can write. ओके इंटू आता हे इकडे राईट साईडला मूव्ह केला म्हणजे आपण तो नंबर वाढवला तर हा नंबर कमी करायचा. किती डिजिट 1 2 3. तर हे विल 10 raised to 6. ओके टी स्क्वेअर याचं सपोज आपण स्क्वेअर रूट घेतलं. लेट मी टेक स्क्वेअर रूट. फर्स्ट ऑफ ऑल स्क्वेअर रूट ऑफ द 10 raised to 6, that is 1000. So it will be 10 cube. Okay, into square root of 375. 3.75. It's 1.936. So that much time you required. 1.936 into 10 raised to 3 seconds. So एवढ्या स्लो ते हळूहळू पुढे सरकणार आहे. ओके खूप हळूहळू. सो टाइम खूप लागतोय त्याला. ठीक. सो दॅट इज वॉट द ऍडिशनल क्वेश्चन फ्रॉम युअर यूज युअर ब्रेन पॉवर. ठीक आहे. चला आता आपण नेक्स्ट बघूयात. आय होप की हे तुम्ही लिहिलं असेल की पॉज करून लिहा. लिहिलं नसेल पॉज करून लिहून घ्या नंतर. ओके मी हे इरेज करतो. Next, this will be from the page on your page number 7. Calculate the gravitational force due to Earth on Mahendra in earlier example. So again, gravitational force is find out करायचं, but due to Earth's gravitational force. So इथे तुम्हाला mass of Earth लागेल. Mass of Mahendra आहे तुमच्याकडे. Mass of Mahendra is 75 kg. Mass of Earth लक्षात ठेवा 6 into 10 raised to 24 kg. Then radius of the Earth, that is nothing but the distance. Radius of Earth. So it is 6.4 into 10 raised to 6 meter. Okay. And capital G 6.67 into 10 raised to minus 11 Newton meter square per kg square. Okay. So here let us use first the formula for the gravitational force. F is capital G. The mass M1, that is nothing but the mass of the Earth. Okay. Let's say mass of Earth into that mass of the Mahendra into radius the square. So put all the values 6.67 into 10 raised to minus 11 into mass of the Earth is 6 into 10 raised to 24 into mass of the Mahendra is 75 divided by R, that is 6.4. Just a minute. Into 10 raised to minus 11 the square. Now again you need to simplify all these. 10 ची पॉवर आहे त्याचं कॅल्क्युलेशन नंतर करा. पहिला 6.67 into 6 करा. ओके 6.67 into 6. So हे असेल तुमचं 40.02 into 75 नंतर करा. हे इकडे आपण करू 10 raised to minus 11 10 raised to 24. ओके 24 minus 11 it will be 13. हे होईल तुमचं 10 raised to 13 divided by आहे तुमच्याकडे 6.4 चा स्क्वेअर. 4 into 6.4 it will be 40.96 into 10 raised to minus 11 चा स्क्वेअर आला 10 raised to minus 22. So इकडं again 40.02 into 75, it is 3001.5 divided by 40.96 into हे minus 20 वर गेलं की plus 20 होईल 22 होईल. ओके सो plus 22 आणि हे 13 35. सो हे मिळेल तुम्हाला 10 raised to 35. ओके इकडे आपण डिवाइड करू 3001.5 divided by 40.96. It is 73.278. So I can round up that to 8 into 10 raised to 35. So याला परत आपण 7.3 again 7.33 into याचा एक डिजिट इकडे कमी केला ना डेसिमल पॉइंट मध्ये मूव्ह करताना, तर याचा एक डिजिट मग वाढवायचा. It will be 36. Okay, so that is what the gravitational force applied by the Earth on Mahendra. Hmm? It's 733 Newton only. It says 733. What is wrong here? Yes. So हे आपण -11 इथं लिहिलेलं आहे. -11 का लिहिलं इथं? हे 6 आहे ना? It will be 6. 6 so हे 12 होईल. होईल -12. ओके. हे -12 जर वर गेलं तर ते होईल 13. नो सॉरी मायनस कुठे आहे 6 आहे सो हे जस्ट 12 होईल हे -12 वर गेलं तर हे 13 -12 1 होईल जस्ट 10 होईल ओके सो 10 35 आपण खोडून टाकू हे इथं सो इट विल बी 7328 सो आय कॅन राईट इंटू 10 केलं की हे असं होईल हे 8 याच्यात राऊंड ऑफ केलं की 3 होईल हे जस्ट 733 हा इथे एक चूक झालेली बघा इथं आपण 10⁻11 नाही आहे हे 10⁻6 आहे याचं डबल 12 होणार आहे इथं ओके तर ही आपल्याला काळजी घ्यायला पाहिजे चलो नो इशू so its answer is 733 Newton. Okay. चलो अगेन पॉज करा लिहून घ्या now next question on that same page number starting from rest what will be the Mahendra's velocity if u is 0 meter per second Mahendra's velocity after 1 second time is 1 second uh okay so final velocity we need to find it out falling down due to gravitational force so force आहे आपला 733 न्यूटन ओके आणि हा ग्रॅव्हिटेशनल फोर्सला सपोज तो महेंद्र खाली पडत असेल तर त्याची फायनल वेलोसिटी काय सो अगेन फर्स्ट ऑफ ऑल वी नीड टू फाइंड आउट द एक्सलेशन हियर ओके because with the if you want to solve questions with the help of Newton's equation you need to have the acceleration there okay so acceleration is nothing but force upon mass so force is 733 divided by mass is 75 kg mass of the Mahindra is 75 here हे आपण आधी पण बघितलेलं आहे सो हे किती होईल तुमचा आन्सर so that will be your just a minute 9.77 9.77 meter per second square. Now, uh, let's find out the final velocity. So you can use the first equation first. Using Newton's first equation, that is V is equal to U plus 80, where V U is 0 plus A is 9.77 into T is 1. Okay. So simply you will get V is equal to 9.77 meter per second square. Okay. So yeah, it's simple equation. Hmm? And this is actually 1.83 times into 10 raised to 9 times more than Mahendra's velocity. Okay. तर हे खूप जास्त आहे चलो हे सुद्धा एकदा पॉज करून व्यवस्थित लिहून घ्या लेट मी सी हाऊ मेनी एक्झाम्पल्स आर रिमेनिंग एक दोन तीन चार चार राहिलेत ठीक आहे एक काम करू ही चार आपण वाटलं तर नेक्स्ट नको हे घेऊन टाकू एक हे जे राहिलेले असतील ते नेक्स्ट क्लासमध्ये आपण करूयात अजून एक क्लास बघूया याच्यावर ओके चलो सो बाय बाय ऑल टेक केअर कीप लर्निंग